Here's an example where you own a business and you believe weekly profits are normally distributed with a variance of 100 squared and a mean of 400. So let's just quickly write out what that is. So we believe that X is distributed normally with a mean of 400 and a variance of 100 squared. Now let's suppose we get new management and you take a random sample of 8 weeks of data. We're going to make a one-sided 90% confidence interval for X bar. All right, so let's go ahead and graph out with this information that we have. What we want here is we want to look at some distribution here for X bar. And we want to find the 90% confidence interval, a one-sided, so that 90% of our data is to the right of that line. That means 10% of our data is going to be over here. Well, what I know then is that X bar minus mu over sigma squared over n, the square root of that, will be distributed normally with a mean 0 and standard deviation of 1. Well, if this is the case, then I can look up the z-score right here for 10% on our table. So let's go to that table. Here is our z-score. So I am looking for 10%, which happens right about here. So we'll call that as close as we can to 1.28. So it's 1.28, and that's our z-score that we found. So we come here, and so this z-score is equal to negative 1.28. So now we can go into the probability that negative 1.28 is less than X bar minus mu over the square root of sigma squared over n is equal to 0.90. And now all we have to do is now plug and chug the things in the middle. So this equation from the middle is 1.28 is less than X bar minus mu. Well, we know mu is 400 square root of 100 squared over, and now we have 8 weeks of data, so that n will be 8. And now we can go ahead and solve this. So this is going to equal negative 1.28 times the square root of 100 squared over 8 plus 400 is less than X bar. And we find this, and that 354.75 is less than X bar. And so we come up to our distribution. That means if this is our population distribution centered around the mean, then we are 90% certain, so here's our 0.10, that this value, and our mean here is 400, is that our X bar is going to be within this range, and we're 90% certain that happens. So that's how we can find a one-sided confidence interval with this example. Now we have that example. Now let's add one small piece to this. So the same setup, but now the question is, what happens if we observe that X bar is equal to 350? Are profits under the new management lower than they used to be? Well, in this case, what we can do is we can actually do a hypothesis test where we set up our null hypothesis, in this case that our mu is equal to 400, and our alternative is that mu is less than 400. And now we can choose our alpha. In this case, let's choose an alpha of 10%. So we're doing a one-sided test. And so if this is the case, now we can use the same thing we just used, X bar minus mu over square root of sigma squared over n. because we know sigma squared, this is distributed as a standard normal, or as a normal with 0, 1. And so now with this is same thing we had as with our confidence interval. Now we can draw out this normal distribution, which is now centered around 0, which is the difference between x bar minus mu. And we can set up our rejection region based off of that same negative 1.28. And so it's building off that same notion we did with the confidence interval, that 90% of our data is over here, and that alpha is equal to 0.10, which is this area to the left. And now I can calculate my critical value by looking at my t-stat, or my critic. I can set up x bar minus mu over the square root of sigma squared over n. This is equal to x bar is 350 minus 400 divided by the square root of 100 squared over 8. And so this equals negative 1.414. Well, negative 1.414 falls right here, which is in our rejection region, which means that we would reject the null hypothesis that mu is equal to 400. Or in other words, similar to what we had this confidence interval, is that if our x bar is 350, based on this distribution, are profits under the new management lower than they used to be? Well, we can conclude that yes, we're 90% certain that the profits are statistically significantly lower than they used to be, or that they're less than 400. And that's kind of the relationship between confidence interval over here and hypothesis testing over here. Very directly related, but we can use confidence intervals to conduct hypothesis tests.